Okay, today's objective of the lesson is to use the division properties of exponents to simplify. In order to simplify, the first thing we want to take a look at is the warm-up. The warm-up is regular numbers, and oftentimes when we're working with exponents, we forget that the coefficients work like they always have in the past. In other words, between 20 and 28, we want to find a common factor. The common factor between both of them is 4. So we're dividing both of them by 4, and so we are left with 5 over 7. In number 9, we find a common factor of 5, and when we take that 5 out, that negative comes to the top. So we end up getting negative 10. Each of these are problems we're probably pretty simple, we're familiar with. And so in number 3, when we reduce this fraction, we take out the 15. We want to take out as the most or the largest factor that we can. So for negative 15 over 30, we get 1/2, and we keep the negative on the top. And we have to have that 1 on the top because we have to have a place marker in the numerator. Whereas if it's in the denominator, we do not need to have the 1 in the denominator. In number 4, we no longer have numbers, but we have variables. And variables, we're going to take out what we can that's common between the top and the bottom. So we have an a in the top and an a in the bottom. When we reduce those, they become 1, because a divided by a is just 1. Now we don't have to write that every single time, but here we have another set that are common between the top and the bottom, and we're left with a squared in the numerator. And we don't have to put anything in the denominator because anything divided by 1 is itself. In number 5, we've got several b's in the numerator and several b's in the denominator. We're going to reduce the 6 b's in the numerator. All of those become 1 because we're dividing them with the 6 in the denominator. When we do this, we're left with 1 on the top, and then in the denominator we have 5 b's left over, so it's b to the 5th. So when we're reducing fractions, we're trying to eliminate common factors. In the numerator and denominator. When we're working with exponential expressions, a problem is simplified when there are no negative exponents. When no variable repeats. In other words, if you have x squared times x to the 3rd, we want to simplify that to x to the 5th so that variable doesn't repeat. And that's true for the numerator and denominator. The last one is we have no parentheses when possible. Sometimes it's inevitable we're going to have parentheses, but for most of these we can get rid of the parentheses. In other words, if you have parenthesis negative x all raised to the 3rd power, this can be simplified to negative x cubed without the parentheses. If you have negative x, that whole thing is squared, this can be simplified. Because there's 2 negatives, that's going to be a positive, we have positive x squared. So we can get rid of the parentheses, and we want to when possible. Alright, let's take a look at some of the rules that we have for quotient of powers product. The rule states if you have a to the m divided by a to the n, notice we have the same base, then we can just subtract the exponents. That is a to the m minus n. And a cannot equal 0. That's the case for most of our bases, that we don't have it equal to 0. So when we're simplifying the next couple examples, we want to make sure that we have no negative exponents. Alright, so in this one, the 4 is the same, so we have more on top, so our 4 will be on the top, and we have 4 to the 1st. Here with the b, we've got negative 3 as our base, but we have the same number on the top and on the bottom. So we end up getting 1 in this case. Or you take 4 minus 4, which is 0. Anything to the 0 power is 1. In letter C, the first thing we want to do is simplify the numerator and then we'll work with the denominator. So in the numerator we have 6 to the 8th over 6 to the 9th. Now we can take the numerator minus the denominator and we get 6 to the negative 1, which then goes in the denominator. Or we can just pay attention to the fact that we have more 6's in the denominator. So we'll have 6 in the denominator, 9 minus 8 is 1, so it's just 1/6 as our final answer. In example D, this x squared is naturally in the numerator. Although it doesn't say it's not exactly in the numerator, we can rewrite this as 2x squared over x to the 4th. Now one of my friends likes to say, what you do is you find where the larger exponent is. Now the 2 is just naturally on the top. Since the larger one is in the bottom, we write the x in the bottom, and we do big minus little, stick it where the big is. In other words, 4 minus 2, stick our answer down where the 4 was. This way it takes care of everything positive and negative. So with an example E, the A has the larger exponent on the top, so we're on the top. 3 minus 2 is 1. Stick that exponent, we don't need to write 1. And the B, the larger one is on the bottom. 5 minus 4 is 1, and again we don't write 1 as the exponent. Alright, the next rule, which we've kind of already worked with a little bit, is the power of a quotient property. This says if you have a quantity A divided by B raised to the m power, it's the same thing as A to the m over B to the m. Again, in this case, B cannot equal 0 because we can't divide by 0. So in example E, we've got 1 cubed over 4 cubed, which is the same thing as 1 over 64. In example F, the 2 only sees the 4 and the x. It does not see the negative out front. So our answer will be negative. We've got negative 4 squared over x squared, which is negative 16 over x squared. In example G, we've got that negative 4 sees everything. So there's two ways to deal with this. One is to distribute the negative 4, so we have 3 to the negative 4 over 2 to the negative 4, and then flip everybody. The 2 in the denominator comes up to the numerator, we get 2 to the 4th. The 3 goes down to the denominator, and we get 3 to the 4th. We can evaluate this. 2 to the 4th is 16, and 3 to the 4th is 81. In our last example, this 3 sees every exponent. The x has an exponent of 1, as does the 2, the 3, and the y. All of them have an exponent of 1. So we get 2 cubed, x cubed, over 3 cubed, y cubed. And then we can simplify. 2 cubed is 8, x cubed, and then 3 cubed is 27, y cubed. Let's continue with some more practice. Now we're dealing with expressions that have the variable repeats, as well as we've got some division, and in some cases we even have negative exponents. So let's take a look at example I. In example I, some students like to multiply across, simplifying, and then divide. And that's a good method. So we'll take 3 times 12, which is 36. X to the 3rd and x to the 3rd, since they have the same base, we add the exponents, and we get x to the 6th. Then we have y, and y squared gives us y cubed, over 4xy cubed. And then we reduce. The 36 and 4 have a 4 in common, so we divide by 4, and we get 9 on the top and 1 on the bottom. So let's go ahead and write that. The x to the 6th and x, the larger exponent is on the top, so we have x on the top. 6 minus 1 is 5, so we have x to the 5th in the top. And then the y cubes divide to give us 1, so the reality is our answer is just 9x to the 5th. In example J, let's simplify each one individually, each factor individually, and then we will multiply it together. This 3 here, since it's being raised to a power, is being raised to another power, we're going to multiply. This is a to the 1st times 3, so we get a cubed. Then we take 2 times 3 and we get 6, so b to the 6th, over 2 cubed, which is 8, and b to the third. That's the first expression. The next expression, this -2 sees everything, meaning it's going to flip the inside as well as distribute a 2. So we're going to do both steps in one. That is, this is 4 to the -2, goes down to the denominator, and then it's a +2. A squared to the -2 becomes a to the -4th, goes down to the bottom and becomes a to the 4th. This b to the -2 was in the denominator. It's going to come up to the numerator and become positive. Okay, so now we have this expression that we can simplify. And we can multiply straight across, and we get a to the 3rd is on the top, b to the 8th. And then we're going to have to take 8 times 16, which is 128. B to the 3rd, a to the 4th. All right, we're going to go ahead and simplify because we have variables in the numerator and denominator that repeat. So the 128 is going to stay in the denominator. For the a's, the larger one's in the denominator. So we have a in the denominator. 4 minus 3 is 1, so we don't have to write that. And then the numerator, or excuse me, the b is the larger one in the numerator. And we have 8 minus 3, which is 5. So our final answer is b to the 5th over 128a. In this last example, this is kind of previous what we've done in the past. This 3 sees everything inside, so we get 3 cubed, which is 27, x to the 6th divided by y to the 3rd. Everything is positive, there's no parentheses, and a variable doesn't repeat, so we're good. All right, let's take a look. We're going to skip to example Q. In example Q, we have a lot of stuff going on. First of all, what's on the inside is not simplified. So we're going to go ahead and simplify what's inside. The 3 is fine and the 2 is okay. As we take a look at the x's, there's 2 ways to deal with this. One is 5 is the larger number. Since it's the larger number, our x is going to go on the top. And then you can just do big minus little, stick it where the big is. 5 minus a -2 becomes 5 plus 2, which is x to the 7th. The other way to deal with that is since it's a -2, it goes up to the top, and then you add the exponents. Either way, you're going to get the same answer. Same thing with y. This y to the 8th is the larger, so our y is going to go on the top. We take 8 minus 3, which is 5. So we have y to the 5th on the top. This is still raised to the -2 exponent. Now this -2 says everything inside is going to flip. Whatever's in the numerator is going to go in the denominator, and whatever's in the denominator is going to go to the numerator, and it's going to double all of the exponents. So we're going to take the 3, we're going to put that in the denominator, and then we're going to square it. We'll take the x to the 7th, put it in the denominator, and we're going to double it and get 14. This y goes to the denominator and becomes y to the 10th. The 2 goes up to the numerator and becomes 2 squared. Remember, a negative exponent just flips it. So now we have 4 over 9x to the 14th, y to the 10th. All right, this concludes the lesson. You've got plenty of practice to look at and to try the division property of exponents. And then we'll come back together and review all of the steps together with using multiple properties in one.